Hello everyone, welcome back. I am Vijay and today I shall discuss how to create a node which will trace cycle using Python package. In our previous sessions, I have introduced you to the ROS2 commands and for publishing on topic and calling services to trace cycle and then subsequently explain how to create the shell script that can trace the cycle. And in this particular session, we'll be using Node. So let's get started. So a quick recap for the typical program structure of ROS2 node. Uh, we see that ROS2 node is having three main methods. One is main method, second is node class and callback function. So main method, the standard lines in general are we have to initialize the RCL file and then we have to create one or more nodes and we process that node using spin. This RCL py.spin starts the event loop that is waiting for the messages and the communication when they're shut down. And in the node class, we have created here this node circle timer. That's a subclass of the node main class, and then the super defines the name of the node, and then one publisher publish the twist message type on turtle 1/cmd velocity, and this will be subscribed by the TurtleSim node, and then we'll be creating a timer of this frequency 1, that is 1 per second, and draw circle callback will be called after every second as given here. Then you can set velocity or do something, and this draw circle is called at this hertz. So this complete code is available on my GitHub repository. You can download it from my GitHub repository. So for example, if one traces circle of radius 1 unit, center at 3, we need to move our turtle from initial position. When we start turtleSim node, the initial position is 5.5, 5.5. And then it is always better to bring this turtleSim from this position to this position to have this 3, 3 at circle. So when we are moving from 5.5, 5.5 to this, we have to set pan off, and then we have to move using teleport absolute service. Then we can assume any linear velocity, and then we can calculate the angular velocity using V by R, and R is given as 1 unit. And then we can calculate the time to trace one complete circle. So it is 2 pi by omega. And that for that much time, we have to publish the command velocity. So that is what basically is essential to understand. And before publishing to the to that particular topic, we have to set pan on so that it start tracing. And finally, when we have to stop, so we will be making an eye on this time, how much time is elapsed. So once the time elapsed is equal to t, then we will be publishing 0 velocities to stop that turtle. And then again, we can set off the pen and then we can go for the other kind of work. So the complete code is here. So complete code we have created one publisher, then set the linear velocity and angular velocity, calculated the radius as V by R, and then we have calculated the time required for this, that is 2 pi by omega, and then we have called the draw circle function or the method. Then the draw circle method we will be publishing, because draw circle method is called here, and in the draw circle method we will be publishing the command velocity topic. We will be publishing the message on that CMD velocity topic. So this is the twist message type is twist. So this twist is the object that we have created, and then we set the linear and angular velocity. We started the clock start time, and then the current time is set equal to the start time, and here we have started one while loop for publishing the message, twist message that we have created here, and this will publish till the elapsed time is less than equal to circle time. And after that, we have basically calculated the current time within the loop and set the current time, and then again checking whether the current time is when at the time elapsed is less than equal to circle time. And finally, to stop the turtle, we will be publishing this blank. When we give the blank, it is taking all velocities as zero, all linear and all angular velocity. So that is how it is created. So you can no doubt download it from my GitHub page, and then we can see the demo of this. So once you download, you can Colcon build it, and then source the setup dot bash from the install folder, and then if I press run this using ROS2 run command, this will create exact one circle, and it is mentioned here the radius of the circle is 1 unit. Time for circle that we have calculated is this, and completed one circle in 3.14 seconds. So that is how we have created one circle, and now we'll be trying to understand how this complete cycle is traced. So again, you can download this cycle.py from my GitHub repo, and then we can try to understand what exactly is the structure of this node and how this node is created. You can find this file on GitHub, so you can search for GitHub Wizardon. You'll find this link here. First link you will click, then you will get this ROS2 repo, and in the ROS2 repo you can click on the cycle. Either you can copy paste it or you can download it, and once you download, you get you can open this in VS Code. So if you have not created the package, I have created one package turtle, test turtle, and you can create this package in the SRC folder. So I can go to the SRC folder, and here I can create the package in ROS2 pkg create in the name of the package, that is test underscore turtle, and then the build type. If I do not provide build type, then it will create the CPP package, that is C++ package. Otherwise, I have to give the build type, that is amend Python. So if I click this, I get this directory already exists, so that UI is not creating. So I already package is already there. If you do not have package, go to the SRC folder and then create that package. So once package is created, now we are ready to go, and you can download this and copy the file in the test turtle. This is the name of the package, test turtle. Within the test turtle, you have another test turtle folder, and there you have to copy it cycle.py. So let us now try to understand what the cycle.py is. So as we already discussed, that in the main we have only the few commands for essentially. One is to initialize the RCL pi, then the node that we have created, and then the spin to start the event loop and the shutdown. So in the node, that is cycle node, we have created a subclass of the node main class, and in the init because when we instantiate this node, then this init function is run, and here we have created one publisher to publish the twist message type on turtle1 CMD velocity, and then we have created two client to send the request on teleport absolute type service type on the turtle1 teleport absolute uh, service. And similarly, the another, you can say, service client we have to create for this service turtle1 slash set underscore pen, and the service type is set pen. So these two service clients we have created in the init, and then we call this draw cycle method. So in the draw cycle method, if I open this draw cycle method, so here it is the draw cycle method. In the draw cycle method, first we'll be creating frame as we did in our previous session. Then we draw seed by drawing square, and then we'll draw wheel, and finally we'll be moving our turtle back to the top of that seed. So let us start with the drawing frame. So in the drawing of frame or tracing frame, first of all we will be moving, because when we start our turtle sim node, certainly we can see this is the 5.5 and 5.5 in position. So initially we are here, but we have to start the first column, that is from 3.5 to 6 at 3.56, and then we'll be moving 3 to 3, that is the center of the first wheel, and then from 3 to 5.55, that is the center of the seed, and then coming to the next center of the rear wheel, that is this. And no doubt the colors, I have created one particular method, that is teleport method, where we are sending request, sending teleport request. So in this, let us now understand how this teleport method that we have created is sending request. And you have to also see we are passing this RGB and this off parameter also in the teleport method. So here is the teleport method, where this xy, the coordinate to which we have to teleport, and then the RGB for set pen service. So this is the send request method for test set pen, and this is the send request method for teleport. So these are the two methods which are called in the teleport. One is what is the behavior of the pen, what is the color, whether it is off and on, and then the actual teleport absolute request. So let us first see what the send request set pen method is, and certainly as the name suggests, we will be sending the request to this to set the pen. So we'll be calling this call async for asynchronous calling the request, and then we will wait and the node will spin until this feature completes. So unless until feature complete, we will not go beyond it. Otherwise, this service which we have requested will not set, and it will go further forever, as we have called this asynchronous calling and getting the feature. So that is how we have the set send request set pen, and similarly we have the send request teleport, and in this we'll be using this teleport absolute request and setting this x and y value, theta values, and then again calling this asynchronously, and because we want that this to finish before all other commands are executed, and that is why we'll be using spin until feature complete. So unless until we get the feature, it will not go beyond it, even though we have called the service asynchronously. So this completes our draw frame. Now coming to the draw square. In the draw square, you can see we have again the teleports, and based on where we want our uh, turtle to move to trace that particular uh, seat. And finally, it is the two circles that we have to draw to represent wheels, and it is not very tricky because trick we have already understood. And the wheels, we have to first teleport to the circumference of that wheel. So this 3 comma 2 is the circumference for 3 comma 3 circle, that is the front wheel, and then we will draw a circle. The another method is called to draw a circle, so it means it will be uh, publishing the masses on this command velocity masses. So here we are first basically setting the span of false so that it uh, turns on the pen, and then the object of this twist masses type, then setting this linear velocity and the angular velocity using speed and radius, which we are calling. So the method that we are using here, and if you see here, we are only passing one particular argument because the other missing argument will be 2.0. So this method of representing or defining as methods is very appropriate, so that even if we do not pass some argument, the default values are taken. So in this case, speed will be taken as 2. So speed is 2 and radius is 1, so it means omega will also be 2. And we are setting here the timer, not exactly the timer, we are keeping watch on the time that is already elapsed, setting the start time, and then checking the elapsed time. It has to be equal to the time of drawing one circle. So it is again 2 pi by omega. And then till that time, we will be continuously publishing on this topic using this massive object that we have just created. And once this complete circle is done, and then we will set these twist masses as 0. So that is how we can draw circles. So now we can see how this particular cycle is plotted. So I have to polygon build first. So polygon equal package select, and the package name is turtle test underscore turtle. So once I build this, now next is to source this. Source install setup dot py and a setup dot bash. So this will source the overlay that we have just created, and then we can use ROS to run. Package name is test underscore turtle, and I'm using the convention of writing the executable name as the cycle underscore exe, and the I have mentioned exe after each to represent that these are the executables. So I have used cycle underscore exe. So if I run this, you will find that it is drawn very quickly. Few things have been drawn very quickly, and the circle is slow. If I want to increase, for example, the speed of plotting circle as well, so what I will do, I will make changes in the velocity. So the C radius we have to keep same. So I have to change the velocity in the draw wheel. So here I have specified the velocity. So circle is 1. So suppose, for example, I make it 6, speed as 6. Then let us see how this behaves. So again, I have to call conbuild, and then the source, and then this. So now it is creating the one. I'll just basically clear this first, and then rerun this. So at one place I have changed the speed, the other place I have not changed the speeds, and that is why one circle is being placed very fast and another circle is not that fast. So that is all for this today's session, and we learned so many things in this, how to trace a bicycle, changing the color of the pen, and then teleport absolute service. So that's all. If you find this tutorial helpful, don't forget to like this video and subscribe for more such tutorials. Until next time, happy learning. Thank you.